This video briefly introduces omnidirectional dual-polarized antenna, using co-located slots with Wedgy profile. This work proposes a wedge-profiled antenna with both considerations of electromagnetic and aerodynamic performances for supersonic onboard systems. This work was finished by Professor Yulis Group from Tsinghua University. More details can be found in the homepage or group WeChat. In the fighter systems, many types of antennas are installed on the fuselage for multiple functions. To reduce windage, the antennas are usually low-profiled. However, with the development of the fighter, the antennas are required with higher performances. For example, omnidirectional radiation for full azimuthal coverage, and dual polarizations to avoid polarization mismatching. To achieve these performances, the antennas occupy more space and enlarge the windage. So, it remains a challenge to realize an antenna with both low windage and high performance. The key point to solve this problem is the profile. For example, the antenna can be designed with wider bandwidth, if occupying a larger profile. Besides, different antenna profiles will result in different values of windage. Hence, both electromagnetic and aerodynamic performances are limited by the antenna profile. Based on the aerodynamic analysis, it can be observed that the case of wedge profile has the smallest windage coefficient, and the smaller angle of wedge will result in lower windage coefficient. So, a wedge is selected as the main profile of the antenna. In this work, based on this Wedgy profile, a metal cavity is designed with co-located slot structure. For horizontal polarization, two identical half-wavelength slots are etched onto the cavity sidewalls symmetrically. Meanwhile, a folded slot is carved horizontally for vertical polarization. These two modes of dual polarizations are orthogonal, so the antenna achieves a high port isolation in such a compact Wedgy profile. As seen from the experimental results, the port isolation between dual polarizations is higher than 42 dB in the overall operating frequency band. Besides, the antenna also achieves omnidirectional radiation for both dual polarizations. Compared with the other omnidirectional dual-polarized antennas, the proposed antenna occupies similar space, but realizes a very small windage. It proves that using a Wedgy profile is the better design for the supersonic fighter. In a whole, a wedge-profiled antenna is proposed within a compact volume. For low-windage supersonic onboard systems, the co-located slot structure within the Wedgy profile realizes a high port isolation and omnidirectional radiation for both dual polarizations. More essential, this work proposes an approach to design the antenna with the collaborative considerations of both electromagnetic and aerodynamic performances. More details about this work can be found in the